Good morning, children. Today we are going to learn about distance time graphs. The change in the position of an object with time can be represented using distance time graph. We can even calculate the speed of a moving object by using distance time graph. The most important point to be remembered while learning about distance time graph is time has to be taken along x-axis always and distance has to be taken along y-axis. These graphs can be studied for various conditions of an object. Object at rest. An object can have uniform speed. An object can even have non-uniform speed. In this graph, if you observe, time is taken on x-axis and distance on y-axis. First, let us see the coordinates of the points plotted on the distance time graph. Starting from the first point, we have the coordinates as 0, 100, 1, 100, 200, 300. Here, the values of y coordinate represent distance and are same. But the values of x coordinates which represent time are different. That means the object is at the same distance from the origin with change in time. The object is at the same distance from the origin with change in time. In simpler terms, we can say there is no change in the position of the object. It is at rest. So, the distance time graph for an object at rest is parallel to x-axis. See the coordinates of the points in this graph. Take all the coordinates of every point on the graph and make a table with two columns, time and distance. Then you will have in the time column 0, 1, 2, 3. Whereas the corresponding distance for time 0 seconds will be 0 meters, and for 1 second the distance is 50 meters, 2 seconds 100 meters, 3 seconds 150 meters. If you observe the values of the points, the coordinates of the points, you can say that the object is covering equal distances in equal intervals of time. So, the object is starting from the rest position and is having uniform speed. The graph for such an object with uniform speed will be a straight line passing through the origin. The way we have done for the last graph, that is for an object having uniform speed, we will tabulate the coordinates of the points in the two columns even here. Then we will have in the time column the values as 0, 1, 2, 3, 4. The corresponding values in the distance column will be 0, 20, 70, 150 and 200. 0, 20, 20 because it is less than 50. Then for 2 seconds it is 70. Then in the third second it is 150 meters and in the fourth second 200 meters. When we observe the table, we can find that object is covering unequal distances in equal intervals of time. Here, the object is said to move with non-uniform speed and the distance time graph is a curved line unlike for uniform speed. Now, we can summarize the three graphs we have studied so far. We have studied the distance time graph is a straight line parallel to time axis when the object is at rest. And then we have seen that when the speed of the object is uniform, then the distance time graph is a straight line. And the distance time graph is a curved line when the speed is non-uniform. Now, let us see how we can calculate the speed of a body from distance time graph. For this, we will take any point A on the graph. From A, we will drop perpendicular AB on the x-axis and perpendicular AC on y-axis. We all know the formula to calculate speed. How do we calculate? Speed is given by distance by time. Now, when the object is at A, the distance travelled is OC, the y-coordinate of the point A. The time taken to cover this distance is OB, which is the x-coordinate of point A. So, we will get speed as distance by time, which is OC by OB, which is also equal to y-coordinate by x-coordinate. But OC and AB are equal. So, we will have speed equal to AB by OB. We will have speed equal to AB by OB, which is equal to y by x, the y-coordinate by the x-coordinate. This value of y by x is known as slope or gradient of the graph. Slope or gradient of the graph is y by x. The slope of a distance time graph gives speed. Now, let us see how we can calculate the velocity of an object from a given distance time graph. Remember, distance or displacement and speed or velocity, they have the same meaning in graphs. Now, in this graph, you have to calculate the speed. We already have learned that speed is given by the slope of the graph. Actually, slope is nothing but the inclination of the graph with the x-axis. Inclination means the angle made by the graph with the x-axis. The slope of the graph can also be determined when 2 points are given. We can use the formula y2 minus y1 by x2 minus x1. But we know that on the y-axis we are taking distance and on the x-axis we are taking time. So, between 2 points, y2 minus y1 will become equal to s2 minus s1 and x2 minus x1 will become t2 minus t1. So, we will have slope of this graph which is shown by using the formula s2 minus s1 by t2 minus t1. In the figure, they have given us d1, d2 for the distance. Generally, we have learned that we represent distance or displacement by using letter S. That is the reason why I am saying slope is given by s2 minus s1 by t2 minus t1. Now, there is a question for you to know how far you have understood about distance time graphs. The figure shows the distance time graph for the motion of 3 cars A, B and C. Compare their speeds and tell which moves faster and which moves slowly by observing the graph. Yes, car A, which has more slope, it moves faster than the other two. And car B, I think it's car B, which has less slope and is moving with the least speed. In the next module, we are going to learn how to describe the motion of a body using velocity time graphs.